Good morning to all of you. So I think I'm audible. So till now we have discussed about uh, different components of the flexible pavement and rigid pavement, different characteristics of the materials, and different tests associated with the material testings of flexible and rigid pavement. Now, in this class, we'll discuss about the design parameters of the flexible pavement and what are the different components of the flexible pavement design. Now, the flexible pavements have been modeled as a three-layer structures. So, so in our previous class, we have discussed that flexible pavements are made up of different layers. Okay, now here for the design criteria or analysis of the structure, we will consider this as a three-layer system. Now, what are these three layers? So, first layer is your subgrade layer, that is the beneath layer, then your base or subbase layer, and then surface layer. So, these three layers we will consider whenever we want to analyze the flexible design structure. Now, in the flexible pavement, there are different locations where stress and strains are generated, and these important positions or locations are called critical stress location. Now, different stresses which induced in the flexible pavements are vertical compressive strain at the top of the subgrade, which can cause subgrade deformation, resulting in permanent deformation at the pavement surface. Then horizontal tensile strain or stress at the bottom of the bituminous layer, which can cause fracture of the pavement layer and pavement deformation within the bituminous layer. Now, if this is a flexible pavement, see these are the three layers. One is binder course, then granular base or subbase course, and subgrade soil or subgrade course. Now, your compressive strain would be generated just above the subgrade layer, and because of this compressive strain, some permanent deformation will occur. Okay, now because of that permanent deformation, that deformation will be get carried out on the top of the surface. So, your subgrade strength is very much important for the design of the flexible pavement, because if the subgrade fails, in that case, because of this compressive strain, there would be some dip in the subgrade soil and it will eventually seen over the top surface, and this type of failure of the flexible pavement is called rutting. Okay, so rotting is a permanent failure and which you have to repair. Other than repair, there is nothing else you can do about it. So this type of failure is called rotting failure. Now another type of flexible pavement failure is called fatigue failure, where this flexible pavement fails due to the tensile strain which is generated at the bottom of the binder course or top of the granular subbase course. Okay, this is the tensile strain. Now, because of this tensile strains which imposed at the bottom of the binder course, because of that, some crack will be generated over the surface. Okay, some cracks will be generated over the pavement surface. And when this crack is more than 20%, in that case, we will say that the pavement has failed. Okay, so this type of cracking is called fatigue failure. So primarily there are two types of failure. One failure is fatigue failure and another failure is rutting failure. Now for the rutting or permanent deformation, when the depth of the rut hole is more than 20 mm, in that case we will say that the pavement is failed due to the rutting. So these are the some design criteria of the flexible pavement. Now coming to the next question, there are two failure criteria for the flexible pavement. One is fatigue criteria and another one is rutting criteria. Now fatigue criteria say that bituminous surfacing of pavements display flexural fatigue cracking if the tensile strain at the bottom of the bituminous layer is beyond certain limit. So it means that if the tensile strain generated over here is exceeding a certain limit, in that case, that fatigue failure will occur. Now the relationship between the fatigue life of the pavement and the tensile strain in the bottom of the bituminous layer was obtained as this equation. Okay, where NF is the number of load repetitions. Now, one thing you want to remember that in the flexible pavement or in the pavement design, whether it is flexible pavement or rigid pavement, what happens whenever you are testing that in the laboratory setup, you don't impose any direct compressive stress or tensile stress over the pavement portions. Instead of this, you will impose some repetitive applications of the load, because in the field also the load would be repetitive. That is, vehicle is moving, so that load would be repetitive cyclic load. Okay, so that load would be repetitive cyclic load. So for this reason, for the flexible pavement design, we have repetitive cyclic load, and because of this repetition, we have to count that what numbers of repetition that a particular tire or particular load can be rotated before the failure of the flexible pavement before the fatigue. Okay, so this is the equation where NF is the allowable number of load repetition, that is the total number of load repetition, and E is the elastic modulus of the bituminous layer. E is the elastic modulus of the bituminous layer, and epsilon E is the tensile strain which is generated at the bottom of the binder course. Now see this equation. This equation signifies that what is the total number of load repetitions a pavement can take. Okay, before it fails due to the fatigue failure. Now, in these equations, whatever parameters or values are written over there, that values are basically found from the empirical test for some particular grade of the bitumen. Now, if the grade of the bitumen and material characteristic changes, in that case, this equation also changes. So, your basic equation would be your this layer NF or your allowable number of load repetition is inversely proportional to your Young modulus of the bituminous layer and your tensile strain generated at the bottom of the surface. So that is the basic equation. Now fatigue cracking is due to the buildup of tensile strain at the bottom of the asphaltic concrete layer or binder course. The pavement is considered failed if 20% of the surface has cracked. So if you are considering a surface of suppose 1 meter square, in that case if 20% of the surface has cracked, in that case you will say that the pavement is failed due to the fatigue failure. Now, similarly, there is rutting criteria. Okay, so in the rutting criteria, the allowable number of load repetition to control the permanent deformation can be expressed as NR equal to 4.165 into 10 to the power minus 8 1 by EZ, where EZ or epsilon Z is the your compressive strain generated at the bottom of the base course, granular base or sub-base course. Okay. Now, rutting failure is due to the buildup of excessive compressive strain at the top of the subgrade layer. The pavement is considered failed when a rut depth of 20 millimeter is there. So whenever some rutting depth of 20 meter or 20 millimeter is there, in that case you will say that the pavement is failed into the rutting failure. So there are another type of cracking is there. So your fatigue cracking would be over that binder course or over these portions. Okay, your rutting failure would be generated over there and it will be gradually transferred to the top surface and ultimately it will be created a pothole over the road surface. Okay, so these are the layer system, that is layer 3 which is subgrade course, then layer 2 which is granular base or subbase course, and layer 1 it is surface course or binder course. Now, another important thing is, so whenever you are designing a road section, in that case, you have to first calculate what is the total number of load repetitions for the different vehicles. Okay, now the method considers traffic in terms of cumulative number of standard axles to be carried by the pavement during the design time. Now, what is this standard axle? Now see, in the road, there are different type of vehicles which have different configurations and which have different type of loads. Okay, loads combinations. So for the design purpose, we will consider only the vehicles whose weight is more than 3 tons. Okay, so lesser than this value, whatever vehicles are there for the design purpose, we will ignore them. Okay, so we will consider the vehicles which weight is more than 3 tons. Now, if there are more than 3 tons, in that series also there are different type of load combinations. Suppose some vehicles may have a weight of 3 tons, some have 5 tons, some vehicles may have 7 tons, some may have 8 tons, 12 tons, like that. So in that case, we need to convert all these loading values corresponding to a particular standard value, like the PCU concept. Okay, so this standard thing is, or standard load is 8160 kg or nearly 8 tons. Okay, so this is the cumulative number of standard axles. So whatever load repetition we will observe over the surface, we will convert this into cumulative number of standard axle considering our standard value as 8160 kg. Now for this we need some information. So what are this information? Initial traffic in terms of cumulative commercial vehicles per day, and the commercial vehicles are designated as the vehicle which weight is more than 3 tons in the design purpose. Then traffic growth rate during the design life. Why traffic growth rate is required? Because suppose in 2019 you started to build a road project. Okay, now during that time, suppose there are X number of vehicles over there. Now your road construction will take some time, like suppose 3 years or 2 years or 5 years, something like that. So after that, that number of vehicles will be increased proportionally, okay, as per the growth rate of the vehicles. Therefore, you need to consider the growth rate of the vehicle so that your road would be useful after the design of the road surface. Now, design life in number of years, generally there are different type of design lives which you need to consider based on the importance of the road. Generally, a flexible pavement is designed for a time period of 10 to 20 years depending on the importance of the road. Then vehicle damage factor, that you need to consider this, and distribution of commercial traffic over the carriageway, and that is called vehicle distribution factor. So one is damage factor and another one is distribution factor. So we will discuss these things. So first one is initial traffic. So initial traffic is determined in terms of commercial vehicles per day. So for the structural design of the pavement, only commercial vehicles are considered, assuming laden weight of 3 tons or more. So this thing is important. You will consider only the commercial vehicles with a laden weight of 3 tons or more, and their axle loading will be considered. The estimate of the initial daily traffic flow for any road should be normally be based on 7-day to 24-hour classified traffic count. So you have to count the traffic, that is classified traffic count, that is what is the different numbers of vehicles which are running over the road as per their category, and this type of survey you have to continue for the 7 days and for a total period of 24 hours in each day. Now, in case of new roads, traffic estimates can be made on the basis of potential land use and traffic on existing roads in the area. Otherwise, you can do this thing by using a OD survey, that is origin and destination survey. So, through this origin and destination survey, you will have a basic idea about how many numbers of vehicles can be moved from that place to another place which you are intended to connect through a road. So in this way you will get an idea about the traffic conditions over the road in case of new road. Now next is traffic growth rate. How we will consider the traffic growth rate? Now traffic growth rate can be estimated by studying the past trends of traffic growth by establishing econometric models, and if adequate data is not available, in that case you can consider traffic growth as 7.5%. Now, if you have the enough data for the previous years, in that case, you have to find out what is the growth rate considering the last 3 to 5 years. Okay, so you have the data of the traffic in different years, and you have to find out at how much numbers of vehicles is increased from the previous year. So from this data, you can easily get to find the growth rate, and that growth rate you can directly use. Now, if you do not have enough data, in that case, you can use 7.5% as the traffic growth rate. Now, design life. So, as I have already discussed, that design life varies according to importance of the road. So, for the national highway and state highway, you will design considering a design life of 15 years. Now, for expressway and urban roads, it would be 20 years, and for other type of roads, it would be 10 to 15 years. These are the design life considering different factors. Now next thing is vehicle damage factor. Now the vehicle damage factor is a multiplier for converting the number of commercial vehicles of different axle loads and axle configuration to the number of standard axle load repetitions. So we have already discussed that whenever you are considering the traffic, your standard loading condition is 8160 kg, and you have to convert all the loading configurations and load in terms of cumulative, that is standard cumulative repetition. Now for this you have to multiply that one with a factor to convert this into a standard one. Now that factor is called vehicle damage factor. So it is defined as equivalent number of standard axle per commercial vehicle. Now the VDF varies with the axle configuration, axle loading, terrain, type of road, and any form region to region. So there are different parameters of the VDF value. It changes according to different conditions like your axle configuration, axle loading, terrain, type of the road, etc. Now, the axle load equivalency factors are used to convert different axle load repetition into equivalent standard axle load repetition. So, for this equivalency factor, you can refer IRC 37 2001 for further information. So, in the IRC 37 2001, there are different data are available. So from that PDF data, you can easily see what are the VDF values of different type of vehicles. So 8160 kg is our standard axle load. Generally, that is the standard load for a truck. Now, next factor is vehicle distribution factor. Now, this factor is also important. Why? Because see, suppose there is a certain road, and in that road, suppose some vehicles are moving. In that case, they will particularly follow some path. Okay, now if they follow, if that road is only a single lane road, in that case they will follow a particular path. Okay, because they do not have any space to move in either direction. Okay, so in this way they will cause some damage to the road surface. Now, if it is a double lane road, in that case that would not be as defined as of the single lane road. In that case, see, there are distributions of the load among the different lanes. So in the two lane, there are two lanes. So distributions of the load would be in two lane. Okay, so vehicle distribution factor is a factor which considered all these factors. So there are different conditions, and based on these different conditions, you have to take the vehicle distribution factor. Now, for the single lane roads, traffic tends to be more channelized on single roads than the two lane roads, and to allow for this concentration of wheel load repetition, the design should be based on total number of commercial vehicles in both the directions. So if there is a single lane road which is divided by some divider, in that case, for the design purpose, if it is a single lane road, you have to consider total number of commercial vehicles loading for the design purpose. Okay, so whatever numbers you have found out from uh, your traffic survey, the total loading should be considered for the design of single lane road. Now, for the two lane single carriageway road, the design should be based on 75% of the commercial vehicles in both directions. Now, if that is a two lane road, in that case, you can have used only 75% of the commercial vehicles in both the direction. Now, for the four lane single carriageway roads, the design should be based on 40% of the total number of commercial vehicles in both directions. And for the dual carriageway roads, so dual carriageway road, okay, it would be like that. Dual carriageway road, it would be divided like that. For the dual carriageway road, it should be based on 75% of the number of commercial vehicles in each direction. For dual three-lane carriageway and dual four-lane carriageway, the distribution factor will be 60% and 45% respectively. So based on the different parameters of the road, that is whether it is single lane roads or whether it is two lane road, whether it is multiple lane roads. So based on all these parameters, you have to multiply another factors with the your loading condition, and that factor is called vehicle distribution factor. Now you know for our flexible pavement design that subgrade is the most important portion, and we have to ensure that our subgrade is of enough strength. Okay, now this strength is checked by generally severe test and plate load test. Now the thing is, for our design purpose, generally the plate load test is preferred, and from the plate load test you will get the modulus of separate reaction E. Okay, that is required to find out the fatigue life and rutting life of the pavement. Now, this plate load test is generally a complicated one. Either you need much more time than the severe test, and stress setup is also little bit complicated than the severe test. Therefore, a relationship is established between the severe value and the modulus of separate reaction value. And this relationship is the modulus of separate reaction E is equal to 10 times of the severe if the severe value whatever you get is lesser than 5%, and your separate reaction E is equal to 176 into severe to the power 0.64 if the severe value is more than 5%. So these are the modulus of separate reaction of different type of bituminous surface force is given based on the temperature. Now for the asphalt concrete, AC is asphalt concrete and dense bituminous macadam. In that case, your base force would be your bitumen mixed with the aggregate, and it would be denser with a 80 to 100 grade bitumen. Your for the temperature 20 degrees Celsius is E value is 2300. So like that there are different type of mixed type, and based on this mixed type there are different temperature, and based on the temperature there are different types of modulus of separate reaction values. Now, another thing is your Poisson ratio that is also required. So, as suggested in IRC 37 2001, your subgrade and unbound granular layers, your default value of the mu is or Poisson ratio is 0.4. For the bituminous layer, at 35 to 45 degrees Celsius, your default value of the mu is 0.5, and default value of mu at 20 to 30 degrees Celsius is 0.35. Now you have to compute the design traffic. So this is the formula for the design traffic, where n is the cumulative number of standard axle to be catered for in the design in terms of MSA. MSA means million standard axle. So it would be 365 into 1 plus R, where R is the traffic growth rate to the power n, where n is the total life of the pavement which you want to consider. So here, because of the different type of pavements or different importance of the pavement, there are different type of design life. So suppose you are designing a national highway, in that case here n would be 15 minus 1 into A. A is the initial traffic in the year of completion of the construction. I will explain this term, where D is the lane distribution factor and F is the vehicle damage factor. Okay, so A is the initial traffic in the year of completion of construction in terms of number of the commercial vehicles per day. So how, suppose you are designing a road in the year 2020. Now the total construction would be completed suppose in 2023. So here A is the what is the total number of traffic in the year 2023. So how you will calculate this? You will calculate this using this formula, where A is P into 1 plus R to the power X, where P is your initial traffic, that is the last traffic count which we have considered, that is number of commercial vehicles for the last count. R is the growth factor or annual growth rate, and X is the number of years between the last count and the year of completion. Suppose you have started the road project on 2020 and you have the data for traffic data for the 2018, and it will be completed in 2023. So here X would be 5, that is 2023 minus 2018, that is the total year, that is the number of years between the last count and the year of completion of the construction. Now coming to the next portion, that is the component design. So there are different components of the flexible pavements and how you design this different component of the flexible pavement. So first one is subgrade. Now this subgrade should be compacted to 97% of the dry density achieved with heavy compaction. So whatever subgrade is there, you have to compact this to 97% dry density. Okay, and you can use some water for the better compaction or consolidations of the subgrade. So when this maximum dry density achieved, when your moisture content is optimum. So to know the optimum moisture content, you can do the Proctor test to find out the optimum moisture content. So often you have seen that some rollers are rolling over the subgrade course or your embankment, and they are spreading some water over that subgrade over that soil layers, and after that they are trying to compact this with the roller. So basically this roller are used to compact the soil, and your water is sprinkled over the surface of the soil to achieve that maximum dry density. So for expressway, national highway, state highway, the material used for subgrade construction should have the dry density of not less than 1.75 gram per cc. So that is your minimum value for your construction. Suppose you have compacted a particular portions of the embankment or soil subgrade, okay, with the help of roller and sprinkling water. So after that, so suppose you think that now our compaction is over, in that case what you have to do, you have to collect some sample and you have to find out what is the dry density of that particular material. Now if dry density is lesser than 1.7 gram per cc, then you have to again compact it. Now if it is more than 1.75 gram per cc, in that case your compaction is over. Now you can build the other portion or construct the other portions of the road. For determining the CPR value, the standard test procedure described in IS 2720 should be strictly followed. Okay, so you already know about the CPR test. So whatever parameters and whatever components of the CPR test are there, and whatever procedures is associated with the CPR test, all these procedures should be followed. So during our discussion about the CPR test, we have discussed that there are two types of CPR test. One is soaked CPR test and another one is unsoaked CPR test. So whenever you are performing this laboratory test, you have to consider about these two tests. So if your region for the construction is within a heavy rainfall zone area, in that case you have to go for 4 day soaking, and that CPR test would be soaked CPR test. Now if it is in a dry region or arid region, in that case your CPR test would be unsoaked CPR test. The test must always be performed on remolded samples of soils in the laboratory as per the CPR standard. It is recommended that the samples be soaked in water for 4 days prior to testing if there is or if the region fall under heavy rainfall zone, and in situ CPR test is not recommended. So at the site that CPR test is not recommended, you have to perform the CPR test in the laboratory procedures, the laboratory environment. So this is all the considerations which we will consider during the subgrade preparation. Now another thing is your subbase layer. So subbase is generally it is called granular subbase materials are conforming to clause 401 of MOD, that is Ministry of Road Transport and Highway Authority, specifications for road and bridges works is recommended. Now the subbase material should have minimum CPR of 20% for cumulative traffic up to 2 MSA, that is 2 million standard axle, and 30% for traffic exceeding 2 MSA. So first you have to find out what is the total traffic. So after that you have to find out what is the severe value for the for the subbase force. Now if the severe value is more than, if your cumulative standard axle is 2 MSA, in that case a severe value of more than 20% is required. And if your severe value, and if your total traffic loading is exceeding 2 MSA, that is 2 million standard axle, in that case, a severe value of 30% or more is preferred. Now, the material should be tested for severe and the dry density and moisture content expected in the field. So, you will directly collect the samples from the field conditions, and after that, you will test the sample so that it can match with the field condition. The thickness of subbase should not be less than 150 mm for design traffic, less than 10 MSA, and 200 mm for the design traffic of 10 MSA and above. Okay, so this is the minimum thickness. So minimum thickness is 150 mm for your design traffic less than 10 million standard axle loads, and it should be 200 mm if the traffic exceed or design traffic exceed 10 MSA. Then preferably a subgrade soil should have a CPR of 2%. Okay, if there is if the subgrade CPR is lesser than 2%, in that case you have to treat the soil with different materials like cement slurry, cements, or other type of stabilization material. If the CBR is lesser than 2%, the design should be based on CBR of 2% and a capping layer of 150 mm thickness of materials with a minimum CBR of 10% shall be provided in addition to surface. So in that case, you have to provide another layer in addition to the surface, and that is compacted subgrade where the CBR value should be more than 10%. So where stage construction, this type of construction is adopted, the thickness of subways shall be provided for ultimate pavement section for the full design line. So I am ending the class right now because that meeting will be automatically stop after some time. So again, you have to join to the class using the same link.